This video examines one pathway by which we can create a knowledge filter in order to increase the value of technology education within academia. This model has two paths. The first is rigor and research. The other is an epistemic justification for technology education. The audience for both of these paths are fellow technology educators and researchers, other STEM educators and researchers, and policymakers and administrators. Although the outcome is the same, these three distinct groups need separate messaging that is directly related to them and how we are viewed or what we do as a field. We need to create value in what we do by addressing both perceived and real deficiencies among our peers and in other disciplines. The first of these deficiencies is rigor in research. A quick Google search of journals in both technology education and math and science education reveal that technology education journals do not have some of the key features that make science and math education journals valuable within academia. The first is an impact factor. Impact factors are used by universities and faculty members to determine the value or help determine the value of a publication within a journal. Technology education journals are generally not indexed, which precludes having a valid and accepted impact factor. Top math and science journals, on the other hand, are both indexed with reputable indexing services such as ISI or Web of Science, and have adequate or exceptional impact factors. While there is some argument as to the veracity of these numbers and these metrics, they are used to value the publications and research within a given discipline. If technology education is to be valued, we must increase our research profile and increase the visibility and value of our journals given the current system. The other leg of our filter model that needs to be addressed is an epistemic justification and basis for technology education. A recent book that came out last year says that technology education is still without a recognized epistemic basis, and that this is one of the major challenges that still needs to be addressed. The problem lies in that same problem was pointed out to the profession more than 20 years ago in 1993. For us to be taken seriously within academia, this problem needs to be addressed so that we can show where we fit within epistemology and what type of knowledge we help construct and disseminate as a field. Simply put, epistemology is the theory of knowledge. This theory is broken into two basic categories: propositional knowledge, or knowledge of what, or knowledge of that, such as I know that one hydrogen atom combined with another hydrogen atom gives me hydrogen gas, or I know that two hydrogen atoms and one oxygen atom gives me water. Technology education predominantly lives in the practical side of epistemology, also known as non-propositional or performative. This side of epistemology deals with knowledge how. I know how